State refers to any action in the system that depends on the memory of a preceding action, and the data that must be remembered is called state information. For example, compare two sets of directions. The first one says, walk south for 1 block and take the first right. The second one says, turn right 1 block after you've passed the market. Well, the second instruction requires you to remember that you've passed the market, so it's stateful, whereas the first one does not require you to remember anything, so it's stateless. Whether a system is stateful or stateless has a lot of influence on design, and in particular, you have to decide where to store state information, how to retrieve it, and what to do if it's lost.
So the first thing we'll start to focus on is state and solution, because state is the cornerstone of any cloud-based design. So many design discussions in this class, we will focus on the question of where state information is located in the system and how it's going to be maintained. So here we're going to discuss the problem of where do we store system state. And we're going to show how that leads to a general solution for the design of large-scale cloud-based services. So let's take an example. So stateful versus stateless. Say you're a chef in a kitchen. Well, you could build everything yourself. You could cook the proteins, you could cook the vegetables, you could make the sauces, and you could do the final plating. And what that gives you is a lot of control. It's very easy to troubleshoot because you're very focused, and you can identify issues before they become problems and then fix them before you get to the end state. Problem with that is scale. It's very, very difficult to scale. It becomes a single point of failure, limitation, etc. So even if you look at Henry Ford, they developed the assembly line. Well, a chef's kitchen is perfect for that. Now you'll have different stations. One's responsible for the proteins, the vegetables, the desserts, the plating, etc. So this allows you to focus on scale, and it also allows you to troubleshoot a single area and get very, very good at it. Where here, when you centralize everything, there are a number of different components that could potentially fail the overall dish. But in this case here, you can certainly handle scale and you can handle distribution as well. So the question we ask ourselves is, where is the truth in the system? Where your data is centrally located, people need to understand this is the retrieval data, this is my customer data, this is the active session that somebody's going through an e-commerce website. It had better not get lost, and if there is, if there's a discrepancy or database corruption, well, where does that truth lie? So we understand that a central control mechanism can be also the choke point and a single point of failure. So we have to really think about where we're going to be storing stateful information. So how do we deal with state? Well, in our best practices, from what we learned over the years, the best state is no state. So really trying to make this as distributed as possible to employ a larger number of workers in this, and it allows us to relocate the task, it allows us to scale it, deals with fault tolerance, and a lot of other information. Now, where could you store state? Well, it depends on what you're storing. Those could be objects in a database. It could be shared information in memory, right? So you're keeping session information. It could be simple key value pairs. Perhaps you're tracking cookie data, and that is state. You're tracking where the user is going across maybe even a whole suite of websites. Now, what about critical state? Assuming you have to keep track of state, what is the best way to implement and manage it? And this is the question you should always ask yourself. So the scenarios we really want to try to avoid is hotspots. So let's just say you've taken the best practices, you've distributed state across multiple different servers. Now, in this case, we've stored the state with the actual front-end servers that are handling it. Well, the problem with that is you could become a hotspot because load balancing isn't always perfect, and it may distribute a larger number of stateful transactions to a single front end, and that may become overloaded. So what we recommend is you push state off of the actual services that are handling and relying on state. So you push them to a back end. Now, one way to do it is to have a masterful state in which it's actually keeping track of everything, and then you can cache that. Well, if you cache that data could be stale, and it may not be always the up-to-date stateful information. So how do you fix that? Well, you distribute the state. So in this case here, you can still use, say, cloud load balancing to actually map data back to a number of back-end state servers. So now you do get replication. But the problem is you could introduce a little bit of additional latency. So doing replication and finding out and making sure you don't encounter split brain scenarios, etc., can also be somewhat of a new contentious issue. But oftentimes we find that by distributing state, even though you introduce additional latency, it still overcomes many of the other problems. So you kind of live with that, maybe introduce better caching, etc., in the front end. So here's the panacea, right? We just said that one solution doesn't fit all. Well, this one actually fits a lot of scenarios because it's not a single solution, it's a design process. And so here's pretty much how it goes. So you have your front end components, which could be Cloud DNS, which is distributed DNS. You have your HTTP load balancers. Now you have stateless servers. And what that means is these servers don't maintain state, so they can fail very quickly. Imagine what I recommend for a lot of my students is, hey, why don't you use preemptible virtual machines? There's a real challenge. You're going to get an 80% price discount, so the budgeting people like it, but it forces you to think, how can I design this where my service could be interrupted anytime within a 24-hour period, and I'm only going to get 30 seconds notification? Well, I've got my load balancers that could quickly fail over. If I'm not storing state on these virtual machines, perhaps I could store these somewhere on the back end. Well, of course, those back end servers could also be stateless. Oh, darn. Well, then what you do is you'll have a static stateful cluster. Those are the ones that you dedicate resources to. And in these cases, you allow maybe a large majority of machines to be preemptible with some of them static. And it's a great design challenge because it'll make you think, if I don't require state here, I can scale. I don't have any single point of failure. I can distribute that to a distributed set of backend services. Again, no single point of failure. Being able to scale, it can be easy to troubleshoot the application code, but it can be very difficult understanding the application logic, right? Because there could be a lot of inter-process communication. But when we're coming with state here, this is our dedicated cluster maintaining state. It's sharded, it's replicated, and so this can be the static information that we use. So this is what you see a lot of design processes are utilized at Google itself, and this is one of the best practices that we like to pass along.